All right, so in this type of problem, they're saying that the sine of some angle is 15/17, and they're asking us to find cosine and tangent of that same angle. So the way I would approach this is start by just drawing a kind of a random right triangle here. It doesn't matter too much. We don't have to actually get the sides right. All right. And then pick one of these acute angles here to be your A angle. I'm gonna actually purposely pick the wrong side here, or the wrong angle, so I can show you what's going on. So sine is equal to opposite over hypotenuse. So I know the hypotenuse has to be my 17. Right, so I know that part. But then for the opposite side, I mean, you can kind of tell that opposite angle A right here. You can kind of tell that the way we drew our angle, this is not 15 units long. All right, be more like this one would be 15 units long. So you don't have to do this, but I'm going to go ahead and switch my angle here. All right, so I'm going to make that one A, and I'm going to work based off of that angle. See, now it looks better that this is 15 and that's 17. So opposite over hypotenuse, 15/17. All right, and then from here, you're going to have to use the Pythagorean theorem to figure out this side over here. All right, so a squared, b squared, c squared. Now in this one, we have the hypotenuse, so that's going to be our c. So we're going to have 17 squared, and you can let 15, you can let it be the a or the b. Doesn't matter. 15 squared plus b squared here. See, 15 squared, that is 225 plus b squared. And 17 squared, I believe it's 289. Let me go check real fast. Well, let's do it on the internet. 17. Okay, yeah, 289, good. All right, so I get 289 here. And since we're solving for b squared, we're actually going to have to subtract this time. So subtract 225. We'll get b squared equals, oh, come on here. Subtract that, you'll get a 4 and a 6. All right, so 64. All right, square root both sides. And you're going to get b is equal to 8. So this side would equal 8 now. All right, so that's the tough part, is setting up your triangle. It doesn't really matter how you draw it. But after you do that, you're going to have to use the Pythagorean theorem to find that missing side over there. All right, so now if this is angle A, then cosine of A would be the adjacent side. So cosine of A would be 8/17. All right, adjacent over hypotenuse. And then tangent of A would be 15/8, because tangent is always opposite over adjacent. All right, tangent is 15/8. All right, and that was the answer to our question. One thing I want to point out here is that cosine and sine, notice they're 15/17 and 8/17. Sine and cosine are always smaller than 1. All right, because they're always the ratio of the opposite or the adjacent over the hypotenuse, and the hypotenuse is always bigger than those. So sine and cosine are always less than 1, all right, when you're dealing with right triangles here. And tangent, sometimes it's bigger than 1, like in this example. Other times it might be smaller than 1. All right, it just depends on which angle that you're basing it off of.